Welcome to today's Explainer. I am super thrilled you're tuning in because we're tackling an absolutely massive, hotly debated topic in the tech world today. We're going to do a strategic breakdown of programming paradigms in modern AI, relying on some brilliant insights from Aristotle Alphonse, a machine learning engineer and AI research contributor at Anthropic. We're going to completely demystify exactly which languages you actually need to hit your specific career goals.
Okay, let's dive into this. We've got a really tight roadmap today. First up, the big Python question. Second, we'll look at Python versus R. Third, we'll break down the supporting tech stack. Fourth, making your choice. And finally, number 5, the polyglot reality.
Section 1. The big Python question. Do I need to learn Python to get into data science or AI? Now, this is literally the million-dollar question. Every single beginner or transitioning software pro asks this. It's a question with massive implications for your career trajectory, your earning potential, and just your day-to-day workflow. I mean, are you completely locking yourself out of the industry if you don't speak Python?
Well, the short answer is yes, absolutely. If you want the widest possible range of career opportunities and seamless flexibility across the entire tech ecosystem, Python is basically your golden ticket. But, and this is a really critical but, it isn't the only tool out there. As Aristide points out, Python gives you the most flexibility for building production AI infrastructure, but the right choice can actually change if your core objective is highly specialized academic research.
Section 2. Python versus R.
All right, it's time for the main event, a head-to-head matchup between the generalist powerhouse and the statistician scalpel. Now, what's really interesting about this breakdown is how their foundational philosophies are just so completely different. Python is a general-purpose beast. It's built for readability, it's highly scalable, and it absolutely shines in AI, deep learning, and MLOps. It also has a really intuitive learning curve, making the software transition pretty easy with massive frameworks like PyTorch, TensorFlow, Pandas, and Fast API. R, on the other hand, was literally designed by statisticians for statisticians. It is the absolute undisputed king of exploratory data analysis, gorgeous publication-ready data visualization, and advanced stats, relying on brilliant tools like tidyverse and ggplot2. But you know, the learning curve is definitely steeper if your end goal is full-scale application development.
And these core philosophies completely dictate real-world adoption. Python is the dominant force in tech startups, big tech, and enterprise AI. It is the native tongue for web services, containerization, and AWS or GCP cloud deployments. The path here usually goes analyst to data scientist to machine learning engineer to AI researcher. R, conversely, has a total stronghold in academia, clinical trials, pharma, and biostats. In production environments, it's a bit more niche, but it's wildly superior if you need to quickly whip up interactive dashboards using Shiny. So with R, your path looks more like analyst, biostatistician, quant researcher, or academic data scientist.
Section 3. The supporting tech stack.
So here's the thing. Modern enterprise AI, it's a team sport. It is very rarely built in a single language vacuum. Regardless of whether you choose Python or R, SQL is your absolute, non-negotiable baseline tool. Before you can build some fancy neural network, you have to actually extract and query your data from structured warehouses. SQL is exactly how you do that. It's mandatory.
Next up, we have the challenger, Julia. Keep your eye on this one, because it's gaining some serious traction right now. Julia gives you high-performance scientific computing and quantitative modeling, actually matching the raw execution speed of C, but doing it with a beautifully clean syntax. It's a really exciting space right now.
Then we have the heavy lifters under the hood, C++ and Rust. This is actually pretty fascinating. You might write your deep learning code using Python, but those high-level frameworks like PyTorch and TensorFlow, they aren't actually running the heavy math in Python. The core execution engines, doing the real heavy lifting to squeeze out maximum GPU hardware performance, are actually written in C++ and Rust under the hood.
Finally, rounding out the supporting cast, we have Java and Scala. If you find yourself dealing with massive, large-scale big data infrastructure, we're talking high-throughput distributed computing pipelines like Apache Spark or Hadoop, these are the tools you'll be using. They are the absolute backbone of massive data engineering.
Section 4. Making your choice.
So the crucial point is, how do you actually make your choice? Let's look at a highly practical, goal-oriented decision matrix. Choose Python if you want to build modern AI agents, work on large language models, RAG architectures, or prompt engineering. If you're into machine learning, deep learning, computer vision, or NLP, go with Python. Do you want to build automated ETL pipelines, handle MLOps, or just maintain maximum career versatility across full-stack software development and the startup ecosystem? Again, Python is your best bet.
However, you should absolutely choose R if your goal is rigorous academic and scientific research, like hypothesis testing or epidemiology. R is incredible for biostatistics, analyzing drug efficacy data in clinical trials, or healthcare genomics. It's also the go-to for econometrics, social sciences, public policy analysis, or if you need to rapidly build interactive analytic dashboards with Shiny without dealing with all the typical web front-end overhead.
Section 5. The Polyglot Reality.
This brings us to the climax here, revealing a highly empowering truth about mature production environments. And this brilliantly illustrates how top-tier engineers actually work. They rarely treat this as a zero-sum choice. Leading AI labs rely on multi-language integration. They'll use R for rapid initial exploration and generating rich statistical diagnostics, and then they'll wrap those proven models in Python for massive Kubernetes and cloud deployment at scale.
So please take a breath. Language selection is rarely a zero-sum choice in mature AI labs. You do not have to choose just one language and lock yourself in forever. You can leverage polyglot workflows. You can always master one and then pick up another later. There are amazing resources out there like Harvard's CS50P or FreeCodeCamp that can help you grow and expand your toolkit whenever you're ready.
I want to leave you with this final thought. The language you learn first shapes your foundation, but the actual problems you solve, that is what shapes your career. You have the map now, so what are you going to build first? Thank you so much for joining me for this explainer, and happy coding!